All right, we're on lesson 4, scholars. So we've already talked about the night sky and astronomy in general. We've talked about stars. We've talked about planets. Now let's finish the whole list of objects with moons, meteors, and comets. So what is a moon? All right, a moon is an astronomical object that's captured by a planet, and it orbits around and around that planet. Now, unlike a planet, it doesn't have to be rounded. Our moon is large enough so that gravity rounds it into a sphere. But not all moons get rounded like that. Right? The key element is that whatever that rock is, that object is, gets captured by the planet's gravity and goes around the planet in an orbit. Okay? So, our planet is a little unusual. It has one very large moon, right? That moon was formed over 4 billion years ago when a planetesimal, a very small planet, a little bit smaller than Mars, came in and crashed into the Earth very early on while the solar system was still forming. That slopped off a piece of the Earth's crust, and with parts of that planetesimal and parts of our crust, it swirled out into space and was captured, and our moon was formed. And some things about our moon is the reason we have tides. Okay, so there's gravitational pull between our moon and the Earth. Okay, the Earth and the moon are pretty well fixed in their orbital paths, but the water on the Earth can slosh around. And so the water in the oceans gets pulled towards the moon. That's why when the moon is overhead, you have high tide. And when the moon is on the opposite side of the planet, you have low tide. So tying in those ideas of forces and gravity and movement from earlier in the first semester. Another neat thing about our moon is it rotates, so it spins at the same rate as it revolves, okay? So what that means is we always see the same face of the moon. We never see the back side of the moon. We always see the exact same side of it. We may see different phases. Okay, we can see a full moon or a new moon, but the part of the moon that we see is always the same. Cool? All right. In terms of space travel, we have been to the moon. We haven't been back since 1972. We're talking about going back again on our way to Mars, but not anytime soon. All right. Moving on from moons. Let's talk comets. All right. When I was your age, the big buzz was Halley's Comet. Halley's Comet is a comet that comes by Earth every 75 years. And if you're born at the right time, you might see it twice. Now, what comets are these balls of rock and ice and dust. And these are left over from when the solar system formed, or maybe even before the solar system formed, from the dust cloud that was there that the sun formed out of. So it might predate the sun. And these have very long and elliptical orbits. Their orbits aren't close to circular like ours is. Ours is a slight ellipse, but more circular. The comet has a very long and elliptical orbit. They come from beyond the orbit of Neptune, from the Kuiper Belt. Pluto is one of those Kuiper Belt objects, or from the sphere, the halo that surrounds the solar system. So outside of the planetary disk, there's this sphere, and that's called the Oort cloud. So this has the oldest rocks and dust from our solar system, and they make journeys in towards the sun, and as they do, the heat from the sun can melt some of that ice and get this vapor trail, so you get the tail of a comet. The difference between a comet and a meteor in the sky is a meteor is like a shooting star, swoop, and it's gone. A comet you'll see approach. Oops, come on. Comet you'll see approach, and so you'll see it for days and weeks and months, and then you'll see it go back. And then it's gone for dozens of years, whereas a meteor lasts seconds. All right. What a meteor is a meteor is a rock, small rock that impacts the Earth or the atmosphere. And as it hits the Earth, okay, it rubs against the air in the atmosphere. And that friction, because it's rubbing, heats up and turns into a fireball. That fireball we can see as a streak of light going across the sky. Most meteorites burn up before they ever hit the Earth. But if they're big enough and heavy enough, they can reach Earth. We found meteorites that have fallen. If a meteor is big enough, okay, it could cause mass destruction. Okay, one about the size of the island of Manhattan hit 65 million years ago, wiped out the dinosaurs. Those are few and far between, okay, but they do happen. All right, let's blow up these pictures so you can draw them. Here are the phases of the moon. Notice, here's the sun on this side, here's the Earth. Okay? When the moon is between us and the sun, we don't see the lighted phase. It's on the back side, so we see a new moon. Oops, let's go back. Man, what am I doing today? When the moon is on the opposite side, here's the sun, here's the moon, here's the sun, here's the Earth, here's the moon. That's when we see a full moon. Notice, when it's over here, we see a half moon, because half of it is getting lit from the sun. Over here, we'd also see a half moon. I don't like the way the shadows do this, but yeah, this should be on that side. So you see 3/4 half moon. And this is a 28-day cycle. Here's that picture of a comet. Notice the long tail. Okay, that's the ice melting on the comet as it gets close to the sun. We can see that in our sky. Comets last for weeks and months in our sky versus meteors, which are fleeting moments. It's coming in, zoom, and it burns up. They call those shooting stars. Cool. Make sure you fill out your worksheet. We'll see you in class.